I didn't go over this in the lesson directly, but in your book on page 509, there's a nice summary chart here on how to do factoring. And this is worthwhile looking at and understanding it so that you can know how to do factoring in a methodical method and not miss a point in what's going on. So look at this, number of terms. If there's two or more terms, a lot of times the very first thing you should try is greatest common factor. And here's an example. You know, in this little 3x cubed plus 6x squared minus 15x, they factor out a 3x out of the whole thing, and then they get something they can do some more work with or find out if it's prime. Okay? If there's two or more terms, two terms exactly, then you can look to see if is it a difference of squares. If it is, then I'm going to explode it out using the difference of squares methodology. Okay? If there's three terms, I can look for the perfect square trinomial. The perfect square trinomial, remember, is a squared first term, a squared last term, and in the middle, 2 times the square root of the first term and the square root of the second term. Okay, and if that happens, then you can get a plus b squared, and if it happens to be a negative in the middle, then it's a minus b squared. Okay? And then also, if you have three terms and it isn't a perfect square trinomial, then you can look to see is it x squared plus bx plus c. If it is, you can do the factoring and figure out that something that is multiplied together gives you the c value, and m and n values that are added together give you the b value. And if that doesn't work, and if there's a coefficient in front of that x squared term, then you do the same thing, but instead of the m times n equals c, you say m times n must equal ac. So you factor a times c to find your term that you're dealing with. And finally, if there's more than 3 terms, 4 or more, look by factoring.